Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled a novel DL model with IFS and fuzzy feature selection for emotion recognition. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the demonstration which we have recently developed for the research purpose. This is basically detection of the audio emotion recognition, and on the basis of the recognition the recommendation system is there in the terms of the music in order to uh, change the emotions, right? So before starting this video, let's talk about that what this video will cover. In this particular video, we will initially discuss about the application area where this designed application and research will be and can be implemented. Along with that, we will tell that whatever the code we have designed, how it can be executed, what are the software requirements, what libraries it need to execute. Uh, Along with that, we will also discuss about that what exactly the proposed approach is, how we have implemented, what are the current issues with the present systems. Finally, we will discuss about the experimental results and the findings those are achieved after execution of the results. So let's start to the main phase. Initially, let's talk about the application areas. So as the audio based emotion recognition is there, so it is helpful for many of the automated systems, including human computer interactions, where only by speech they can interact with the computer, and on the basis of the emotion certain applications can be done. It is helpful for the communication purpose, as well as it is very much helpful in the healthcare, where the automated systems can be designed in order to understand that how the patient is feeling and what kind of things can be recommended to them in order to uh, improve their current health, right? uh, let's further talk about that what exactly the code is and how it is to be executed. The folder that we are going to provide you will have these much of files with them, in which you just need to run these three files, because we have divided the whole code into three different scenarios, where we have improved the feature extraction model, we have also proposed the classification model, and finally gave the recommendation model. For this you need the Python system installed in your PC, where the Python must be 3.10 or above. Along with that, you need one of the IDE, such as Visual Studio or Jupyter, or you can also run it on the Collab. So here I'm running the whole code in the Visual, so you must have the Visual Studio with them with you. You just need to open the code and it will be visualized like this. Here you can see the folder is visualized here, and you can open these three files. Make sure to have these this model, this JSON file, and X and Y data, which is created by running these files. So initially you need to run this main feature phase where the data set is processed. Now before moving forward, let's talk about what exactly the data set is. Here in this particular scenario, we have used the data set, that is the save data set. So you can get this data set from this particular website. This, it is a Surrey audio visual expressed emotions. You just need to go to the download, and from there you can just download by logging it or registering it. If you don't want to download it from here, you can go to the Kaggle directly and can download it by having the account only. So it is having number of emotions and other related information for the different inputs. So you can get the details of the dataset from here only, right? So Along with that, let's talk about that what exactly the current situation is and what exactly they are doing. So this is one of the base paper that we were following. It is the recent publication in which they have used different feature sets as MFCC, PLPC, and PMVDR, and then evaluated three different classifier based models like QPSO based, and then PQPSO, TLD, and these are the data sets. These are the classifiers. By approach, they have evaluated the results in terms of different parameters, including the accuracy. This is the confusion curve they have achieved. So inspired from this, we have identified that they are using the optimization algorithm in order to improve the classifier. But the features that they were using were the journal like MFCC, and this they are not improving anything in that. So in the proposed work, what we have did, we have given, so this is the code. Let's run it. You just need to select the file, and then you just need to run this code from here, the play button. So when you will click over this, it will start executing. What we have done in this, we have extracted the feature initially in which the MFCC features are initially calculated. After calculating the MFCC features, these features are forwarded to the self-designed classifier. So we are using the deep learning layered model in order to extract the features instead of using the MFCC directly, because by doing this we can get the more information that how the classifiers can get trained from the standard features. So in this is the figure that is in front of you where the samples are shown. So in the code, initially we are processing the data, extracting the MFCC features from them, and then passing it to the self-designed network, and then networks, here you can see we are using its flattern layered data in order to get the features. So these features are further, you can see here it is processing. These features are further passed to the infinite feature selection model. Those are giving the weights, and finally fuzzy logic model is used to evaluate those weights, that whether that feature is to be selected or not. So on that behalf, we can get the best features. These features are then fed to the classifier, which is in the second phase, where we have saved the features from the phase one in the X final and Y data. X final is having the features, Y data are the labels. So we are loading those files, and by using the statistical DL model, which we have designed in order to reduce the complexity and improving the classification rate, we have designed the whole code. So these features are further processed by the network and get trained, and on the training basis the best model is saved. So we have run this code earlier. I can show you the scenario that how it we have done. So after processing the data, we are this is the model details. This is the epochs during the training phase where the loss and other history is given. We have plotted it by using the matplotlib. So this is the training model curve with respect to epochs. This is the training loss model during the training, and further the prediction is done for the test data with the best model. So the test data is further used to extract the performance matrices in terms of accuracy, precision, recall, and F score. These the achieved results are shown here and also are compared with the base paper, which is earlier shown to you, having the outcomes with them. Like you can see here, the outputs were around this. So for the save data set particularly, so we have compared that. It is in the terms of this here, the accuracy curve is there. So this is the graphical representation of the proposed model. So you can see there is a big difference among the accuracy, and our system is much better with respect to the existing one. Even the confusion metrics for the different classes are also shown, that how much results are achieved. Once the best model is saved, we are moving to the recommendation model, where initially the person is going to select the file which is having the this much of the classes as anger, happiness, fear, disgust, neutral, sadness, and surprise. So when the user is going to select the file, so this is the main file executing file dialog, which is going to ask that whether the data is, which file is to be selected. The file is then selected, and then same features are extracted which are used here during the making the data set. So those features are, this is the fuzzy curve that we have achieved after extracting the features through which they are selecting the best features. So These features are further evaluated using the best model which we have saved during the training part, right? So it is giving you the class. So whatever the class is predicted, that will be either 0, 1, 2, 3, 4, 5, 6, 7, because we are working on the 7 different classes. So accordingly, we have made the folder in which we have set few of the songs. Here you can see in the folder, in the recommendation songs, we have few songs for the anger, for disgust, and so on. So accordingly, that particular class will be identified, and that song will be played by using the play song function, which is basically calling the song from the detected class. So this is how the whole model, the proposed model, this all thing is done in order to improve the current system, and further modifications are still possible. So for the PhD or for the masters and for the research purpose, this can be taken as a reference, and can modifications can be made in it. So I hope you people like this video. For more such videos, stay tuned to our network. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.